seem to have done something with my screen, so I can't see actually my mouse. Sorry, here's something. Try to see if this could work. Oh, that's not the right view. Someone must be switched to presenter view. I think it's presenter view. I have it on and try to do like this. No? Maybe click. Swap displays maybe.
Yeah.
Okay, sorry. Thanks for that. Yeah, sorry for the bad start here. Inexperience in PowerPoint. We'll come back later in my brave animations. I'd like to comment on Anna's comment about Lieven's fantastic presentation. It was a very, very inspirational. I'll see if I can be just as vivid and interesting now that we are at this point in the afternoon. The topic for now is called alien waves, but as Lars says, actually you can see the title is called Alien Wave Service Deployment and the challenges that we're seeing going from experiments to live production. And actually the work done here, I will present the work done in the project of JR1 Task 2, but I will also be telling about what has been done since we have also delivered the report and the deliverable, and what are the findings. So this is a joint project from SurfNet, NordGeoNet, and DTU, and this one is not working. It's going greatly. I will just switch to this one. Okay. So, introduction to the project. I will briefly tell you about what it is. As I said, I have been joining this project a little bit later on. So some of the work that I'm presenting here is not even mine. I just stole it, it seems. But I will try to give you a good overview of what has been done. The drivers and motivations about this. Why do we even try to bother with creating these alien wavelengths? And also what is the exact concept of this alien wave. Past simulations, experiments and conclusions. Let's briefly go in to see what has been achieved, what has been done, and what are the conclusions, because that leads us in to next phase, which is the phase where I come in, the OAMP. Basically there is no OAMP in the alien wave setup that we have done, but we are trying to utilize the functionalities of the system in order to make it to get some operation. So there are some different operational aspects when we try to prototype these alien waves that we need to address and that we need to really go into while trying to put this into service. I need to talk to you about monitoring concepts on this exact point, and then also a little bit about the performance of this. We can briefly go into that. And then what are the next steps after that. So basically it fosters here's the project. It started with an idea from a brilliant guy sitting over there. He's called Roland Neutz, and he called NordGeoNet asking whether or not it would be an interest for NordGeoNet to try to establish an alien wave between NordGeoNet and SurfNet. That led to a hero experiment, which was proved, shown the proof of the concept in 2009 in supercomputing. I think it was presented. From there on, it was basically actually a long iterative process of testing, verification, and the experimental results complying with the simulated results, and try to get some conclusions from that. And then basically we come into the part where I start up, where I try to actually take all these conclusions and to try to put it into production in terms of engineering rules and procedures and level and agreements and so. to get an end product. But what are mainly the drivers in this alien wave? So basically, these 4 points I put up here, that's from the deliverable, and it says direct connection of customer equipment to third-party DWM equipment, elimination of expensive transponders at the transition between two DWM systems, elimination of regeneration reduces the power dissipation, faster time to service, cost saving, support of different modulation formats, offers extended network lifetime. That's from the conclusions of these guys. So basically, that's my interpretation of that. It also mentions that it's a way of greener IT, but I think that the key driver for this is basically that there are quite big savings, and we will see later. Okay, briefly the alien wave context. Conventional DWDM systems, we have the normal optical tools like amplifiers, couplers, VSS components, splitters, whatever, comprising end-to-end systems with transponders in each end. In a multi-domain environment, we need to somehow go to the digital layer at this point, because we need to have the exchange of the information, and that of course is capex increasing, and which is something we wouldn't like. So the experiment, or the idea is actually just to, instead of regenerating the signal here, we can just directly inject it into the next domain, which is represented on the blue box here. Sorry, blue boxes. All right. So what did they do? Basically, the idea was to have a. There's more than just only this. This is the current status that we see right now. What we have at the moment is a alien wave going from Amsterdam to Hamburg. Via Hamburg to Copenhagen, and this is traversing the SurfNet network. And from here, as I said, we can just directly inject the alien wave into the NordNet domain, and SurfNet can receive it at the other end. So what we then also did was to add some 10G neighbors here from the NordNet side, and try to manipulate with these 10G neighbors in terms of power and guard band variations, in order to see what are the effects of the actual 40G signal. And that is a big advantage in the system that we have in NordNet, that we have a full control over the spectrum, and we can monitor the power with a quite okay accuracy. That of course needed also to be somehow supported by the simulations we have done. Hopefully the theory and the experiments that we see should comply. So that's what we can see here, that the simulations that we have done, this is they have done, sorry, I can't take the word. These are the simulation results with 10G variation and a constant 40G, and basically I had to figure out this sketch before it took me some while, because when the curve is going down here, it means that there are more bit error rates. This is the bit error rates, so that means that the higher curve here, it means a better quality. So what happened? Well, as we are traversing a quite long stretch up to around 1,000 kilometers, I think it's even more than 1,000 kilometers, then the nonlinearities effects will actually start to influence. And what we see here are the cross-phase modulation effects as the intensity is increasing of the 10G neighboring channels here. So so the study now, this was just simulations, but this was the cross-phase modulation. The guys then asked themselves, well, do we see any self-phase modulation? And then in order to see this, the 10G, they do the simulation with the 10Gs off, and well, it certainly did kick in. You could see that initially the actual performance was better, but then at 7 dB it kicked off. The cell phase modulation kicked in and really destroyed the signal here. More simulations. Tried here now to do a variation of the 40G with a constant 10G to reveal both the XPM and the SPM. And I tried to make this XPM in a 3D manner so that you can see that we have both a varying 10G power. I mean, the red is the 0 dB, 10 dB. It's a constant 10G, but with these three alterations, and a 40G that is increased, and then definitely we do see XPM effects and cell phase modulation effects also. What do we do that for? We try to find an optimum area to work with, and to know where are we with this system. That also then leads to the experiments, and hopefully we see the same thing. Here we see that the curve turning downward here is the prior to that it's more or less flat, but the reason for that is that the cross-phase modulations that the effects that you could see in the beginning here is not evident because we were not able to turn down the VSS components so much before they actually tweak the signal full. So that's that was a problem. But anyway, we could see that the near optimum area was evident here, and aiming for instance, 10 to the minus third bit error rate would give us that would be this point. That would mean that if we do guard band variations, we could see that actually we need to go above 100 gigahertz in order to maintain a good quality. The 10 to the minus third is actually in the Alcatel equipment. It is actually the first threshold level, or the default threshold level for alarms in the Alcatel system. So yeah, you could argue whether or not it's good quality or not, but at least it is, as I say, it is the default alarm. But as I said, you can see here that we need to, in order to stay here for above 3, then we definitely need to go to the green scale, and that's at least over 100 gigahertz channel spacing. So some design guidelines were concluded, and some experiments were of course learned from this. But also in terms of cost, there was a big analysis on what can this bring us, and to bring out the conclusion in this was that the predominant factor of the cost was based when they compared both the capex opex. That was definitely the capex by orders of magnitude. It was much higher, so the opex could actually be left out in this calculation, and that enabled them just to look at this scenario for the capex, whereas the actual capex investments for the Alienwave are half the price of the regenerated capex price. Okay, so briefly to the conclusions. So the simulations that these guys done was qualitatively okay from what they have or compliant to what they've seen in the experiments. There were major XPM effects when the guard band was decreased and the neighboring channels power was increased. Then the thing about the cost, of course there are much more conclusions than this. I urge you to also to go and look at the deliverable and the full report. But this thing about the cost, that is 98% of the cost is actually the capex cost, and it's nearly double in the regenerated situation. I put this one in a bold and a little bit a bigger font, because that is actually with the part where I come in. The OMP, the phrase here they put, the OMP is adequate for the mix of products with few steps needed for a normal operation. I think I interpret that as what we have embedded in the system today needs a bit tweaking, and then we are almost at the same operational step as we are today with other services. I guess that's what they mean. At least that's what we try to aim for. We have this problem with OAMP that also, like Anna's talked about, standardization is lacking for at least for OTS or OMS interworking. At least I have not seen anything. There are some standardization going on for metro application, but for long haul modulation schemes, there's really no compatibility, and as a consequence, we need when we try to put these alien wave into service and work with them, we need to have full transparency in terms of bitrate, for modulation format, spacing, and full control of the spectrum and admission. What do we load? Which channels do we load, and can we turn them off again? But trying to go from the stage of having these experimental results, all these verification results from simulation tools, trying to go further on and going into the to the operational part. We of course immediately started to talk and have meetings with the respective NOCs, SurfNet NOC, NordioNet NOC, in order to let them know, guys, now that we will be injecting some extraterrestrial photons into your system, and you better be careful. But it's not to worry. We will train you, because you should handle these alien wavelengths almost as normal wavelengths. So we have to agree on the responsibilities and some procedures, and we also need to define handover criteria. Here's an responsibility assignment agreement. This assignment should be agreement. Sorry. So basically, trying to have some really simple way of saying who's doing what in terms of when something goes wrong, so that we have a clear, responsible responsible view, and also that we know exactly who to contact when things do happen, and they do. A thing here to notice, for instance, here it's keeping SurfNet spare for SurfNet in Copenhagen. That's NordioNet's responsibility. That's something we of course would like to take in, and also to go and reseed a card, because that's in our interest to try to keep this service and this partnership up running. And that it would be crazy for SurfNet to roll a guy into 1,000 kilometers to reseed a card. We'll of course do that. This one is also crucial, ticket system information exchange. We definitely need to have the same kind of language when we talk to each other in terms of which alarms has arisen in the system, and what does that mean in your system, what does that mean in our system. So this is ongoing work, and yeah, so as I said, this ongoing work, so we are now in the phase of defining and making the processes even better. But also we have to define the monitoring points and how we interpret these monitoring points. Find a technical solution to monitor them. And some conclusions about this, how we could do that, was already drawn to interest, was already pointed out in the report. So it was a low-hanging fruit just to get this done. And what did we do? So basically, we did identify some monitoring points in the beginning as a startup point. You can do it even much more advanced, and you can probably later on we will expand this. But seen from a operational point of view, this is the start point. From Amsterdam to Hamburg, which is the SurfNet domain, and from Hamburg to Copenhagen, we have identified six different monitoring points, and they have each some sort of a correlation that we can map out and see that well, if we have a loss here, is most probably that this is the affected circuit, or this is the reason why. If we look at the Nordinet part, which is the one here, this has been implemented already now, so we have already made these 2 monitoring points, and the way we do it is that we actually just take we mask these optical add-drop couplers here. We define it as a monitoring receive point, but basically what it does is that there will be an alarm sent back on exactly that port, which is then later on mapped into that exact service, which is in the NOC guy that's working. When he sees the list, he'll see, okay, that's the affected circuit of the SurfNet alien wave number 2 or whatever. But how is this done? So basically, we are using Nagios in Nordinet for the host monitoring as a host monitoring tool, and the Nagios script initiates a poll to this to a monitoring server asking for alarm status, and then the server actually does an SNMP poll to the Alcatel NMS. The Alcatel NMS replies with the current alarm list of the service alarms and the actual physical alarms of the element manager, and this alarm list is then filtered and correlated from the monitoring server, and to check whether or not the affected service is actually, the affected port is actually in service or not, and if so, the result is sent back to Nagios. I'm going the wrong way in the animation, sorry. It's not sent back to the Alcatel NMS again. It's sent back to the Nagios system. So, but that's Nordinet. What do we do in SurfNet? So in SurfNet they have another tool called it's called Xenos, I think it's Xenos or something like that. But they do actually also have a measurement point. This the other measurement point we use in Nordinet I just showed you is a E2E measurement point. Which is under development for the perf sonar, but it is a measurement point that we are using at the moment, and SurfNet is also using. They have some problems with their measurement points that we are trying to fix right now, but basically now we are able to get status from both measurement points, and we can just directly via a plugin which is suitable for both systems. We can actually have same alarms sent to the 2 different systems and get the same alarm view, not physical view, but at least the same alarms. So that's the idea. In future, yeah, it could be that we would go for the perf sonar solution. The perf sonar, just to briefly mention it, it's a supported monitoring tool for at the moment it's Ethernet monitoring tool of the SHAN services, and we would like to go there, but of course currently we are a little bit ahead as we are talking about monitoring alien waves. But in principle we could just forward it to one system, these alarms. Okay, performance. So the P in the OAMP, basically again the idea of doing an SNMP polling of the servers, we can extract information on, for instance, this point of the VSS component, and that could give us performance degraded alarms, and we can even manipulate the threshold so that we will get these alarms even before that they actually occur. And this is ideas. And as I say, that would be the next step. In this case, we would actually be able to have some sort of performance data that is also could be sent back to either perf sonar or some other monitoring tool. We could also maybe in time get the beta error rate from the actual system. If we just forward it back to the same tool, The thing is that right now the Alcatel NMS doesn't see the digital layer, so it will not be able to get and extract this information, of course. But if they are monitored by the same tool and the same monitoring point, then we will be able to see the bit area qualities of Siena's signal. Okay, so next steps. We need to finalize. We are at the moment making a new alien wave. It's that we are going to put into service as a real service, and it's expected to be completed at the end of November. And we would like to then integrate this monitoring point, as I mentioned, that SurfNet has, so that the Xenos tool is also showing the same alarms that we see in the Energios tool. So this is also ongoing. They have some problems that we are trying to fix. Then perhaps we could expand the monitoring concept also to include the performance data, as I mentioned, and also we need to collaborate with Persona. Oh, sorry, that was too much fast. We need to collaborate with Persona team to support future alien wavelength monitoring if they are interested. And as far as the initial meetings that we have had with them, they are interested in being able to help here, but at the moment it's not possible. Optimize procedures and processes, because as soon as we have put this into service, we need to do a review whether or not it's correct way of doing it, and that is learning by doing and getting some experience as time goes by. Communication between native and alien management alarm system, that is also could be a solution with a proxy, and we just speak together and exchange information in this way instead. I put that as a question mark. We don't know. It could be a solution. And then finally, a common optical design tool allowing a joint network design. As I mentioned, there was this simulation. This was done on a simulation tool that DTU had. I don't know if they've probably not developed it, but at least they have this tool, and it's quite advanced. But maybe a lighter version of this could be the common optical design platform. Yes, and that's what I have. I put a link here on the report, so if you will be able to get these presentations later, there will a link to the report of that I mentioned. That's it. Any questions? Lieven?
So I just wanted to share, there is some ongoing work in the ITU, I think it's 69.2 for the black link design, and has been taken over. So in parallel there is some work going on in the ITF, which is called management of the black link. It's driven by Bruce Clinton. I think that would really fit in here. I can send you some links, and it's really clean, so that specification exactly. If you go from Bluetooth to an optical black box,
Yeah.
you make some references and also measurement points, so you can actually there are some SNLT
Okay.
stuff behind it.
So it's going on in ITU, you said? I couldn't hear.
So, well, the thing is, I don't really know what the ITU has to do with it, because they were the ones that were defining the black link and the black box approach.
Okay.
And I think what we really want to do is throw it into the ITF to be able to SNLT parameterize it.
Okay.
You know,
I heard about this. It was actually mentioned in their report, I think, maybe. Am I correct? But at least I saw it, but I left it out because I didn't have time to look at these in these.
yeah, I think it's really very much in line with what we got. What we did.
Okay, thank you. Any other questions? Of course.
No, just the motivation for doing alien wavelength is to save some money due to removing
That's just my interpretation of it. I just took out the conclusions in the report, and my interpretation is that the biggest driver in having this alien wave is is seen from the money perspective. That's my perspective. Yeah, it's probably not the other guys, but you could say one thing is that you have this we are so fortunate that we are in an environment that's quite easy for us to entrance to make these trials. So and I think that the carriers are not that fortunate.
And also, I just asking is if you want to use a new band wavelength, is it the transponder cost the only cost you have?
There was some there was a very fast. This was actually a calculation of a 200 gigabit made with Alienwave, or compared to I think it was actually compared with made with 10 gigs and so forth, with some 40 gigs and 200 gigs. So it's a big cost calculation that I have just very fastly went through. But and as I said, they have also looked into the OAMP cost. Sorry, the operational costs in this. But it was in their calculation, and in this setup, we must remember it's on this setup, right? It could be an entirely different calculation on another setup. But on this setup, the highest cost was the CAPEX.
Yeah, because I'm asking because some vendors they split the cost of transponders, the capacity cost and hardware cost. So if you remove the hardware cost, you have the capacity cost anyway. You have to pay. So then you know.
Yeah. That's true.
So yeah, because you can do it, but you can't. Yeah, you can't earn so much as you did before, because also there's some new.
Okay, I don't know.
Because you have a split in.
Yeah, I see your point.
You have a split in the cost of initiating a new wavelength.
Yeah.
So they don't put all money on the transponders or muxponders, but they split it. Then you will have some other quite other figures.
Yeah, that's true. That's true.
But you would still not have the pluggables at the back of the link, right? Now, for 10 gig, that's in the noise. But if you, like 2 years ago, when you look at the CFP cost for 100 gig, it was less in the noise. And it would make sense then to put the transponder in the router and do the black link approach. I don't know. Yeah, because there's the natural classical erosion of the price of the pluggables, right? You've seen it on 10, we see it at about 40 per bit, but we see that we see it all the time happening. So, you know, integrating. I think it's good, but I would shit on that. But I would say you have the same question as you. What's the rationale of doing black links? There's another question to it, is that the transponders are not standardized. Like, for example, the only pack you can use is a standard pack, G709 pack, which is, well, yeah, that's where the magic happens, and everybody's different there. So to have the soft SD pack hasn't really been standardized as far as I know. So interoperability and dynamics, I say it wrong, but dynamics on the optical layer are really bound if it's in a single domain. Somebody mentioned it, I think it was from this side. You know, there is still a lot of work to be done.
There's another philosophical question to all of this as well, because the pricing for the entire DWDM industry is based on very low common equipment costs and higher transponder costs. And the reason we do it that way is so service providers have a pay-as-you-grow model. They only buy a transponder when they have customer revenue, when they have service revenues. So that's where you tend to load the margin. I think the naive assumption with Blacklink is that that will continue if Blacklink transponders appear. Whereas in fact what will happen is margins will go up on common equipment, and it will start to cost a lot more for common equipment, because now you don't know if the customer is going to buy the transponder from you or from somebody else. So I think Blacklink is going to be a very disruptive technology, but in a bad way, I think.
Especially if you go from 10G to 100G, because in 100G, actually one couple of transponder costs almost like your entire DWDM link. So that's
right. But there, I agree with you. I agree with you. But just for the sake of argument, can we talk? Are we allowed to argue or not?
Yeah, we might be running out of time.
Or we can do it. But the thing is, with you're paying a premium now as well, right? For the 100 gig, it's an expensive new technology. A lot of research has been done on it, so you're paying for that. So that will, but you will see it go down as well. And then I think then Jeff comment will kick in, and then and the other comment I want to make is that somebody told me that as well, is that if you look at where the money is spent really on communication as general, think about phone, think about internet, think about mail, think about transmission costs, routers, switches, whatever you name it. Actually, 20, and this is one of those 80-20 rules, right? But just take face value. 20% is spent on transport, routers, transport, as we know it, and all the rest is infrastructure for communication as such, mail service, resiliency, all that, your laptops, whatever you have there. So then I'm thinking sugar. Now we're trying to optimize 20%, which is we're almost down at the stone. You can't peel the stone, but how do you say that in English? And we're trying to optimize that, while 80% is spent on. I don't know how it is with you guys, and I don't want to shoot at Architel, but I will. Is that our IT sucks, right? I mean, you log a case, and 10 minutes later, 10 days later, you get a reply. Thank you very much. I solved the problem myself. Okay, case closed. We've done a good job. So I think that's another philosophical thing as well.
I think it was also I regret a little bit I put this guy with the money because that was just maybe a fast conclusion for me. That's of course, these angles are of course true, and I think that one thing we also did it out of curiosity, at least Nordinet did this experiments out of curiosity, pure curiosity on how would this react in our live production network. Maybe I forgot to say that.
I would like to add one thing, that you could of course go back to cost, but one thing is also that you can introduce new modulation formats in legacy systems by understanding the legacy systems, and that can be done in almost any traditional DWDM systems with the couplers, etc. So that's a way to enhance the existing system and prolong the lifetime of that, and that is of course that is a capex. But it's done maybe with the same vendor. So yes, they have paid for the system, but they will still continue to work with that vendor. So I don't think in that sense it would be disruptive. But I agree that if you don't pay anything for the amplifiers and only put it in the transponder, yes, it will not fit the current way that the deal is made.
And there's also another. In the fact that we're talking about terrestrial networks here, there's a huge business at the moment about submarine networks that both Alcatel, Infinera, Sienna are having a lot of fun alien waving each other's kit at the moment. And we're upgrading 2.5 gig links up to 100 gig and other kinds of crazy things. So the submarine network where it's under the water you can't change it is a really important thing. But definitely the strong agreement that the price modeling is tilted at the moment to give away the line systems, to try and create a pay-as-you-go model. It's how the industry works. But then we've been through the same with SFPs. Some vendors lock their equipment to SFPs. In fact, the 3 vendors you've got here don't. And it's we have to evolve through it. It's going to be a really interesting few years. Upgrading legacy systems is a very important topic. It's going to be good fun.
At least it's nice that that you were not sleeping during my presentation. That's for sure. Thank you very much.
So we have Jan Mardil as the last speaker for today. Talking about the photonic services and the work done by session5 on that.
And others.
Yeah, on those services. Yeah, that's it. And it is so disruptive that Jeff left. Sorry. That's okay. Yeah. So, here we go, Jan.
Okay, thank you, Lars. This presentation is last and least. I'm going to talk about photonic services, especially within the content of GRA1 task 2. So basically very, very short, because we are little out of schedule. So actually some remarks from our deliverable about laboratory and field test of Alcatel-Lucent equipment within Cessna 2 production network. Then a few words on power consumption, again with respect to photonic services. Then the core of this presentation, photonic services. Then I'm going to talk about the European Metrology Project, NEET-FT. Then a few words about PMD emulations. Again, this may be interesting for photonic services. And last topic is photonic services or optical reach. And then I'm going to talk about new photonic services related subtask within GIANT project or GIANT 3 project. So about this Alcatel-Lucent testing, it was, as far as I know, first verification of 100G coherent technology in Cessna or perhaps even in Czech Republic. We tested this system in our lab, on our experimental facility, and finally on Cessna 2, which is production network. Alcatel-Lucent, you can see which equipment was used together with Cisco 15454 multi-service transport platform, which is used in Cessna 2 network. And together on experimental facility, we're using Czech Light equipment. We actually did similar experiments like Rasmus was talking about, effects of filtration, nonlinear effects, self-phase modulation, cross-phase modulation. We tested 600 kilometers of different fibers in lab, then more than 1000 kilometers in Cessna 2. Everything was with error-free operation, so basically it was just alien waves from Alcatel-Lucent transmitted over Cisco equipment. It was really interesting, even in lab it was a mix of different fibers, G652, and both plus and minus 655. With dispersion compensating fibers and different types of fiber break ratings together with 10 gig non-return to zero wavelengths, and it was tested even over single fiber bidirectional transmission without any problems. Something about power consumption. We did this analysis for deliverable for different types of networks like access, edges, core networks, with something which we call consumption indicator estimations. If you want to compare different equipment, again, perhaps this is not so important for photonic services because they are definitely not power hungry. But still, it can be interesting for anybody who's just going to implement alien wave or photonic services. So basically what is photonic service? Just end-to-end all optical connection for new types of application, because we're not going to talk about just 100 or 40 gig big pipes. What is now more important is minimal or constant delay and jitter, and of course best effort as known from IP networks is not acceptable. Of course these we may talk about photonic services as special type of alien waves, usually not so high speed. So I'm going to talk about some advantages and issues, of course. Then about time frequency transfer, which is perhaps the most important application. Sorry, it just should be transfer. And some real-time applications, and with some real results. So basically I believe photonic services were described in deliverable DS111 and 2 from final GIANT architecture. It is basically, as I said, end-to-end and all optical connection between two or more. We can talk even about optical multicast, places in network. It is, we can describe them with photonic paths and allocated bandwidth. Basically photonic services are usually low speed, of course, but it can be anything. It can be 10 gig, 40 gig, 100G. I just couldn't resist just to talk about what is optics and what is photonics, because we're talking about optical networking, all optical networking, photonic networking, and for some people it's not enough, so they are talking about all photonic networking. So basically optics, okay, everything is coming from ancient Greek words. optica, meaning appearance or look. This is quite old word and used even by Isaac Newton in his quite famous book. Photonics is something different. It's just again from Greek word photos, which really means light. It's phos and genitive photos. It is just light. So this word appeared in late 60s just to describe new research fields, lasers, laser diodes, fibers. This is this book from Sir Isaac Newton. So for me it's just basically we could even talk about all optical or optical services, because photonics is just something new, perhaps referring to more advanced and new results. So there are advantages, of course. Erasmus was talking about transparency to modulation format, low transmission latency, constant latency, because everything is just all optical. There are few challenges or issues, because basically service of your all optical service is just limited, because there are no all optical regenerators as far as I know. We are going to test one device in CESNET, but it's quite specialized and definitely you cannot buy all optical regenerators. So this has to be somehow solved, but as far as I know, again, this should be doable. There may be problems in multi-domain scenario, of course, because global management, and it's something which is not general available. And of course, we can talk about this ITUT black links. It's just one recommendation which may help with deployment of photonic services or alien waves. Just few examples of new applications which may require photonic services: interactive human collaboration, high definition video and Cave2Ks with some latency, jitter limits and end-to-end latency. Frankly speaking, I don't know where these numbers came from. It's from some older presentation, perhaps some IEEE magazine. Really don't know. Perhaps Stanislav can help me. Do you know where these? Definitely, this is not first presentation where we have such numbers. So perhaps it was some workshop, some magazine. I now really can't remember.
The MEF have done some work.
Okay.
Fairly familiar numbers.
Perhaps I could find the resource in some older presentation, but not in this one. Yeah. Remote instrument control, remote control of vehicles. Perhaps this is not so important for NRNs. Definitely, we've got two applications which are very interesting. One is comparison of atomic clocks, which is basically time transfer, and another application is just transfer of ultra-stable frequency. So the first practical deployment is just comparison of atomic clock between two cities and networks. It's CESNET and ACONET, Czech Republic and Austria. Basically, it's just transmission of time marks. It's just modulated optical signal, definitely less than 1 gigabit per second. I think it's 300 megs or something like that. Everything started a few years ago on not fire loop tests, but fiber loop tests and GPS assisted transmission. And now we can have comparison of these atomic clocks between two institutions, BEV and Institute of Photonics and Electronics in Prague. And from August, from last year, as far as I know, it is running. It is operational, everything is going through Prague over a DWDM equipment, which is Cisco. This is part is CESNET2 production network, cross-border fiber, and satellite equipment going from Brno to Vienna. So again, it's just mixture of different types of fiber. different transmission systems, different compensation types, because in Cessna 2 we've got DCF compensating fibers. On this cross-border line we've got fiber break ratings. And this service is working, so actually it's more than almost 800 kilometers of fiber. There are different applications, especially this ultra-stable frequency. This was done in France, so Emily can tell you more information, more details about it. Basically, it's just transmission of continuous wave. It's just the frequency of photons. It's the what is really transmitted, or something which can be compared. So it's just CW, continuous wave. There is no modulation. So basically, bit rate is 0. They've got some special equipment because they need really the same path in both directions. So they are using something really quite special, which is bidirectional EDFAs. So again, it is done on Renater production network. And these ultra-stable pulses are just transmitted not through these regular routers or switches. They are just used just to bypass these regeneration nodes and just transmit it independently. I cannot pronounce all of these French names, so I can only repeat that it started back in 2009 with dark fiber loop tests. Then, of course, it was upgraded to 300 kilometers, and now they've got something like 540 kilometers with many bidirectional EDFAs. It looks this equipment is pretty stable and working as expected. Again, plans for future, just you can see the map. And the total length will be more than 1000 kilometers. Something which is called REFIMEVE Plus project. Again, building national infrastructure to disseminate ultra-stable frequency, but with the help of Renater, which is production, again, just normal production network. More experiments on these frequency transfers were done, so this is another one between MPQ and PTB in Germany. Again, 2009 is dedicated fiber, only 150 kilometers. Today they've got almost 1000 kilometers. Again, they are using bidirectional EDFAs and even something quite specialized fiber Brillion amplification. I've never seen such amplifier. The principle is similar to Raman amplification, but not the same. So even I don't know why at PTB they are using such exotic amplification techniques. Again, this is just a scheme of these bidirectional amplifiers. As far as I know, or I was told that the problem is length of these erbium doped fibers, so it must be the same for both directions. So it is not, so they need just one amplifier which can amplify in both directions, and the total length of this fiber is the same for both directions. So of course the question is if photonic services can be implemented on global scale. I would say yes, but of course there are issues. But we've got these examples from Czech Republic, Austria, Germany, France. I would say that accurate time transfer should be okay. Ultra-stable frequency is more difficult, but especially in Europe, I believe it is doable. Another question is if we can go from Europe to, for example, the United States. Submarine optical cables are usually all optical. There is no electrical regeneration, or I was told that by Infinera guys. Of course, you can find perhaps different types of equipment, submarine equipment. Usually these photonics applications are not very high speed, so there should not be problem just to transport such signals over long distances. We can use different techniques, for example, just to use C-band for standard Ethernet OTN signals, L-band for photonic services. Actually in CESNET we are going to implement such trial C-band for standard IP services and L-band for time transfer. Of course we can use part of C-band for photonic services and part of C-band for just normal services with dense grids, not only 100 gigahertz, 50 is quite common today and 25 is available. Few words on new European metrology project, accurate time and frequency comparison and dissemination through optical telecom networks. Is going to study if it's possible basically to transfer time and frequency via optical fiber links. There was first introductory meeting with people from this metrology project, with people from NRNs and from Dante in Prague this year. More information are available on this website, because after that we had this customer empowered fiber network workshop with few NEET FT participants with latest results. I would say that for some people it's only about time frequency, but of course time and frequency is quite important, especially for many fields, not only science but for financial transactions, navigation, and especially for this redefinition of units. It will start with second, but there are other possibilities how to redefine most units. I can only recommend this presentation from Tom O'Brien. It's about something like 90 slides, very nice and very, I would say, it's really not very scientific but really nice presentation on time. This is the map of this NEET FT project. You can see Finland, Sweden, Germany, Czech Republic, Austria, Italy, NPL in the UK. So these institutions should be somehow connected, so we can have this time and frequency transfer all over Europe. How to do that? It's not so easy. Again, what we are going to do with respect to photonic services in GRA1 task 2 is just emulation of PMD, influence of PMD. Up to now it was done for 10 gig. We had very big problems with software, and it took us about few months just to persuade the vendor of this emulation software that they've got some problems, some bug. So finally it is resolved. So now we can continue with our experiments with 40 gig and 100G coherent stuff. Another important issue is all optical reach of photonic services. So basically we are going to do some model based on estimation on optical signals to noise ratio, because usually, or now we are talking about time frequency transfer, so these photonic services are definitely very low bit rates. So chromatic dispersion and PMD, polarization mode dispersion, is not so critical, but definitely we're going to do some practical verification of influence of PMD CD on photonic services and 10 gig, 40 gig production traffic. Okay, so there is one new subtask within GRA1 task 2 called end-to-end photonic services between user premises, started in April this year. You can see 5 objectives, basically provide feasibility and demonstration studies, strengthen research collaboration with vendors, evaluate feedback from NRNs, from research projects, and demonstrate end-to-end photonic services if it's feasible in year 4. So here is what was done. We've got this international connection between Czech Republic and Austria for atomic clocks comparison. So basically this is sort of demonstration study which can be used for other cases. Now we've got few more institutions connected with dark fibers in Czech Republic where photonic services are available. More information again can be found in presentation from CEF workshop. And of course there are other countries like Germany and France with their own experience how to provide photonic services for these new applications. Of course we contacted some vendors, discussed if it's possible to provide photonic services with their equipment. Some results are quite positive. Sometimes it's not so easy because this field of photonic services is still considered by some people like quite exotic. We contacted all NRNs and we got feedback. What I can say, many of them expressed really they are interested in photonic services, especially countries where these NEET FT institutions are involved. Of course, the big candidate for such photonic services is the NEET FT project. And the last point, which is demonstrate end-to-end photonic services. Now some older fiber links from Gen 3 could be used for photonic services. Details are available now and definitely will be processed. I got this picture this morning from Stanislav, so basically this is quite important dark fiber link for NEET FT project between London and Paris. And of course it's very important just to have all information, especially on first or last miles. Without this information it's really difficult to provide accurate description. If these institutions just can dedicate this fiber just for meteorology, or if they want to mix meteorology applications with just normal IP traffic, but definitely this will be done. There is another task about dissemination of photonic services. It is NA4 task 1. I don't want to bother you with objective, but what is really interesting for me, we've got 9 international presentations on photonic services. They were accepted, including United States, Japan and Brazil. This was a surprise even for me, because it looks that we're going in the right direction. I can provide more information about dissemination results. Of course it is available. So thank you for your kind attention. Thanks to all colleagues participating in different projects. Any questions? Yes.
Just a remark here about the amplifiers for the timing experiment.
Yeah.
He asked Mr. Schnatz once, who did the experiments, and he said to get down to the accuracy that they're looking for, you really have to the signal travel back and forth to the exact same path.
Yes.
So these small detours will actually, well, will not make them able to get the required accuracy. So that's why it has to be the same path.
I can only recommend presentation from CEF. Very nice presentations from France, from PTB, from Sweden and from Finland. Okay, thank you.
Thank you. We just have a very small wrap up on some information. First of all, the important thing, the dinner. I would like to ask everybody that is leaving today, just tick mark our dinner sheet up here so we know who is coming, so the right amount of food will be ordered. Then we have the profile sheet that we handed out in the previous break. I'd like you to fill that out and return it to Alberto so we can set the right groups for tomorrow. And then of course thank you to all the speakers and to our vendors, Shenna, Alcatel and Infinera, for coming and showing what they have presented. And for those that presented, if we can have the presentations, that would be fine in PDF format. If they could be available later, they will be published, I would expect, on the Terina website together with the information from the conference or workshop. Any questions for further? Okay, hopefully we'll.
I was listening. Did you say we start at 9 o'clock tomorrow? And
9 o'clock, yes, according to
yes. Okay.
this one, and page 2. And hope to see you, as many of you, for the dinner later tonight. It's at 7, and the address is on the agenda. Otherwise, come and talk with Alberto and me. Thank you. Not really, no, but it could be arranged, yes.
Are you staying in that hotel?
Yes.
Because some people that stay there, maybe, I don't know.
We can meet at the lobby or something.
Yeah, maybe we should start from here. Which time does it take to get
For dinner?